Arrays. Arrays are quite different from C arrays, more like Pascal arrays. Slices, the next topic, act a little more like C arrays. Declares AR to be an array of 3 integers, initially all set to 0. Size is part of the type built-in function len reports size. Array of values. Array of values, not implicit pointers as in C. You can take an array's address, for instance, to pass it efficiently to a function. Array literals. All the composite types have similar syntax for creating values. For arrays, the literal looks like this. Array of 10 integers, first 3 not 0. Don't want to count. Use triple dots for the length. Don't want to initialize them all. Use key, colon, value pairs. Slices. A slice is a reference to a section of an array. Slices are used much more often than plain arrays. A slice is very cheap. A slice type looks like an array type without a size. Create a slice by slicing an array or slice. Valid indexes of will be 0, 1 and len a equals 2. Can also just assign an array pointer to a slice. Next thing is making slices. Slice literals look like array literals without a size. What this does is create an array of length 5 and then create a slice to refer to it. We can also allocate a slice with the built-in function make. Why make not new? Because we need to make a slice, not just allocate the memory.
Slice capacity. A slice refers to an underlying array, so there may be elements of the end of the slice that are present in the array. The built-in function capacity reports how long the slice can grow. Next, maps. Maps are another reference type. They are declared like this. This declares a map index with key type string and value type float. It is analogous to the C++. On a map, length returns the number of keys. Next one, map creation. As with a slice, a map variable refers to nothing. You must put something in it before it can be used. Three ways. Literal list of colon separate key value pairs. Creation. Assignment. Structs. Structs should feel very familiar. Simple declaration of data field. More usual. Struct allow the programmer to define the layout of memory. Next one is structs are values. Structs are values and new struct type return a pointer to a value. There is no notation for structure pointers. Go provide the indirection for you.
Making structs. Structs are values, so you can make a 0, 1 just by declaring it. It can also allocate 1 with new. Struct literals have the expected syntax. As with arrays, taking the address of the struct literal gives the address of the newly created value. This last example is a constructor for point. Methods on structs. Go has no classes, but you can attach methods to any type. Yes, almost any type. The methods are declared separate from the type declaration as functions with an expected receiver. The obvious structs case is mentioned below. Notice that the explicit receivers, in this case of type point, used within the method. Pointers and values. Go automatically indirects differences values for you when invoking methods. For instance, even though a method has receiver type point, you can invoke it on an addressable value of type point. Similarly, if methods are on point 3, you can use a value of type point 3. Thank you very much.